All right, so use Pythagorean theorem to find the length of the missing side of the right triangle. Then find the value of each of the 6 trig functions of theta. Okay, I imagine many of you remember the Pythagorean theorem. Do you know what they're talking about? The ABC thing? Do you remember that formula?
A squared plus B squared.
Yeah, exactly. So the Pythagorean theorem, A squared plus B squared is C squared. So remember when you do that, the C, as far as the order goes using that thing, the A and the B, the order doesn't really matter. All you got to worry about is the C. Which one is the C? The C is always the hypotenuse. Remember that? That's the one across from the right angle, the longest one. That's this side. See how he's across? So the other two, A and B hit the right angle, don't they? But C is across from the right angle. He's the longest side. He's the hypotenuse. Those two add up to be him because he's the biggest, right? So he's the hypotenuse. All right, so that's the first thing they want me to do is just use that. You've done that in algebra, right? So A and B are 8 and 15, so 8 squared plus 15 squared is C squared. What's that? 64 plus 229. Is that 289? I think if you root it, isn't it like 17 or something? Yeah. Use your calculator. 17. So we got C. C is 17. That's the first step. So the length of the missing side is 17. And then it says, find the value of each of the 6 trig functions. So I'm going to write that out for you. You might already know that, but I'm going to write it out. So we good to there. C is 17. Now, if I can go to a fresh screen without rushing you too fast there. I can squeeze them in right down here. Sine of any angle theta is opposite over hypotenuse. You seen that before? Sine, I know maybe half of you have. Sine is opposite over hypotenuse. Cosine, what's the rule for cosine? That's right, adjacent over hypotenuse. And then come on down here for tangent. Tangent is, anybody know? Opposite over adjacent. Opposite over adjacent. So you're going to want to write these down on your 3x5 card also for the exam 2 weeks from today. So we have those 3, and then the other 3 are just upside down, upside down, upside down. So what's the upside down of sine? Does anybody know the one that's the upside down of sine? It's cosecant. We abbreviate it CSC. Cosecant. I could write it out, I guess. Anyway, it's good enough. We just always write it that way. Cosecant. And that's just upside down. That's just hypotenuse over opposite. And then we have the upside down of cosine, which is secant, which is hypotenuse over adjacent. And then we have the upside down for tangent, which is cotangent, and that's adjacent over opposite. So there's the 6 trig functions. I'll show you how we do those once you get those down. And there's a nice little way, you can put them on your 3x5 card, but there's a nice little way to memorize them all at once. What is it? SOHCAHTOA. SOHCAHTOA. I'll say that probably 1,000 times this semester. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So sine is opposite over hypotenuse, right? It basically just tells you these first 3, and then the other 3 are just upside down. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. SOHCAHTOA, that's what everybody uses to remember the first 3. But you can put them on a 3x5 card. SOHCAHTOA, so that gives me the first 3. The other 3 are just upside down, upside down, upside down. Those are the 6 trig functions. All right. Now, what are those? Why are we doing those? Later. Let's just crank them out first off. So here we go. If you all got that copy down, I'm going to go to a fresh screen and look at the picture again. Question? Get it? Yeah. Get it from your neighbor. What was this 7? 17? 17. This was 17. Okay. So now what do we mean by this opposite, adjacent, all this stuff? Well, you guys know this side's the hypotenuse. That we already know, huh? That's the longest side. Okay. Now, here's angle theta, isn't it? Hone in, it's from his perspective. So from right here, which side is opposite of him? The A is. This is opposite him, and the B is adjacent. Adjacent just means next to you, like your neighbor lives adjacent to you. It just means next to you. So this is the side next to the theta. It's touching the theta. So is the hypotenuse, but we just call that a hypotenuse because it's the longest side. So this is the adjacent. That's the side opposite. Now, they could have put theta up here. They will in problems to come. They'll put theta up here. Then this would be opposite, wouldn't it? And that side would be adjacent. But hypotenuse is still hypotenuse. That doesn't change. But the opposite and adjacent would switch, wouldn't it? It's because it's from the perspective of where you're at, right? Just like right now, who's adjacent to you is different depending on where you're sitting, right? So wherever angle theta is, that's adjacent, that's hypotenuse. Okay, so now we can do the SOHCAHTOA thing. SOHCAHTOA, so sine, what is the sine of where you're supposed to put theta? I'm being too lazy. Sine of theta, in fact, let me just, all these words, I don't have room. Let me put it up here. Sine of theta, what is sine? Opposite over hypotenuse, so opposite, 8 over hypotenuse, 17. 8 over 17. Cosine of theta, adjacent over hypotenuse. So adjacent, 15 over hypotenuse, 17. 15 over 17. Tangent of angle theta. Tangent is opposite. That's a TOA there. Opposite over adjacent, which is 8 over 15. And then flip it, flip it, flip it, right? Sine, the upside down of sine is cosecant, so you'll have to memorize that or write it on your 3x5 card. Eventually you'll know it cold. We'll do it all semester. Cosecant is upside down of sine. Secant is upside down of cosine. Just flip it, flip it, flip it. Cotan is upside down of tan. Done. There's all 6 trig functions. Like that. We good with that one? So we started by finding the hypotenuse with a squared plus b squared is c squared. Pythagorean theorem, found that. And then SOHCAHTOA to find sine, cosine, and tangent. The other 3 are upside down, upside down, upside down. All right, we've begun trigonometry formal-like. Okay, so they're giving me, let me draw it right here, a little bigger for you. They're giving me, here's A, B, right angle, C. They're telling me A is 9, so this is 9. C is 41. So first thing, find the missing side. Use the Pythagorean, a squared plus b squared is c squared. So can you find that missing side? Let me let you do that first off. Use your calculator. So, do it over here. We got room here. So, a squared plus b squared is c squared. So the a is 9, so 9 squared. B is, I don't know. And c is 41. So 9 squared plus b squared is 41 squared. That good? So, what's that? 81 plus b squared. Is the door locked? Sorry about that. Is that another one unlocked? If you go out of it, just unlock it as you go. Just turn that little thing. What's 41 squared? 1681. And solve for b. Just subtract the 81, right? From both sides. B squared is 1600. I'm trying to solve for b. What do I... Good so far? What do I do now to get regular? I got b squared. How do I make regular? Root it, right? Just root it, root it. What is that, 40, I think, right? 40. So b is 40. Okay, and now, and then I assume they're going to put, I don't even know, they don't show where angle theta is. Yeah, they don't show.
It says find it for angle B.
Oh, for angle B? Oh, yeah, good, thanks. You guys can see those little words. Angle B, yeah, so that would be, so this, you can see the original diagram. They have a B up here, they have an A here, and this is C. Yeah, the way they do it is they always put the same letters across from each other when they set these triangles up. You know what I mean? Here is point A, or angle A, same thing. Angle A, point A, whatever. Across from it is side A, little a. Here's B, across from it is B, C, across from it is C. Why they're doing that, there's a logical reason as well. Because an angle's opening affects the side across from it, doesn't it? The bigger an angle gets, the bigger the side opposite it gets, huh? That's why they're going A with A, B with B, C with C. So when they say find angle B, they mean this one. So they want this angle. So from that angle's perspective, let's get clear who's the opposite, adjacent, and hypotenuse. This hypotenuse, we always know that. That's the hypotenuse. So from this angle's perspective here, from B, because they're saying from B, which side is, what is A? What is A? Is it adjacent or opposite? It's adjacent because it's next to angle B, and the little b is opposite. That makes sense. B is always opposite B. So, and then you could do the SOHCAHTOA from there, right? Okay, I leave off the rest. Now that you know which is which, just do the SOHCAHTOA thing and flip the other three, and you'll have the other 6 answers. Questions on that? So like I would go sine is it's SOHCAHTOA, and sine is opposite over hypotenuse. So I'd go opposite, that's the 40, over hypotenuse, that's the 41. There's sine, 40 over 41, etc. Do all the rest. The numbers a little bit. Okay, so they're giving me this triangle. They want tangent of 30 degrees. Tangent of 30. So remember SOHCAHTOA. What did I promise? I'd say that 1,000 times. I'm already like at 4, I think. SOHCAHTOA. So TOA, tangent, is opposite over adjacent. Here's the 30-degree angle. It's from that angle's perspective. So this is the hypotenuse, always. Which side's the opposite? The 1. This is opposite. This is adjacent, isn't it? So opposite over adjacent, opposite over adjacent. It's going to be 1 over root 3. Does that make sense how I found tangent of 30 there? TOA, opposite over adjacent, 1 over root 3. Now, you're not supposed to leave roots in the bottom, huh? Remember that from algebra? We never leave roots in the bottom. So that's the right answer. It's just not cleaned up. I can't leave roots in the bottom. So no roots in a denominator. So what do you do then to get rid of that root from the denominator without changing the value of the problem? Multiply by root 3 over root 3. It should be root 3 over plane 3. Does everybody see the bottom is plane 3? Because root 3 is root 9, which is plane 3. So there's the final answer. No more root on the bottom. Everybody see that? So whenever you want to get rid of a root, we'll do that a lot of times. Whenever you want to get rid of a root from the bottom, you just multiply top and bottom. Because that's a big fancy 1, isn't it? I'm doing the same thing top and bottom. I'm not changing the value. When you multiply by a big fancy 1, you don't change the value. It just looks different, but it's the same value. And the bottom, root 3 is root 9, which is plane 3, isn't it? That always happens. Whenever you have the same 2 roots, it's just one of those planes. So like root 7, plane 7. Root 11, plane 11. It's what always happens. So tangent pi over 3. Now pi over 3, I don't see any pi's over 3 on the picture. So what you could do is just convert that to degrees. You might just know what it is. So how do I take pi over 3 and convert it, because that's radians, huh? How do you convert it to degrees? What is pi? 180. Just pop a 180 in, huh? Remember, that's the bridge between the two worlds. Pi is 180. Whenever you see pi, just pop in 180. So that'll be tangent of 180 over 3. So that'll be tangent of 60. So what they're really asking is tangent of 60. Can you do that real quick? Give them tangent of 60. Remember SOHCAHTOA. So I'm not even going to use this triangle. That's just extra information. Here's the angle I want, huh? So can you do tangent there? So SOHCAHTOA, tangent of 60, opposite over adjacent. SOHCAHTOA, opposite over adjacent. So opposite, which side's this is the hypotenuse. This is adjacent, it's next to the 60. This is opposite, it's across from the 60, huh? So opposite over adjacent. Root 3 over 1. We don't leave 1s in the bottom of a fraction. That's just root 3, huh? You don't leave the 1, that'd be considered unsimplified. Like it's doing nothing. Just get rid of it. It's just root 3. There it is. Questions? Okay, so they're giving me sine and cosine, and they want tangent. So there's some special relationships here. Tangent, anybody know it already? Is, what's the relationship between tangent and sine and cosine? Tangent is sine over cosine. Tangent is sine over cosine. So, tangent will be sine 21/29 over, right, that's sine, over cosine 20/29. Everybody good so far? Sine over cosine. Now, that's kind of ugly looking. How do you deal with a fraction over a fraction like that? Call that a complex fraction. What do you do with that? You grab the one in the bottom and you flip it up, upside down. Do you remember that? Why? Why? Because that's dividing. That really means 21/29 divided by 20/29, doesn't it? Right? It's just a big vertical division. That's what a fraction is. And you know what happens when you divide by a fraction? The one on the right flips, doesn't it? You flip the one on the right, remember that? You change to times. So let's just do that. We'll just grab that one, because that's really the one on the bottom is the one on the right. That's the same thing. So we just say, okay, it's 21/29 times the upside down. Everybody see that? Another way you could think of it is dividing is just upside down multiplying. Right? To divide by 2 is to multiply by a half, isn't it? If I said I had half a cookie, that's the same thing as taking the cookie and dividing it into 2 pieces. Dividing by 2 is multiplying by a half. Dividing is upside down multiplying. So I say, oh, you're dividing? Just multiply by the upside down. Same thing. But it's got to be the one on the bottom, because that's when you're dividing by. So that's when you're multiplying by the upside down of. You don't flip the one on the top. It's got to be the one on the bottom. All right, so anyway, these cancel, don't they? And you just get 21/20. That's the answer. So really, having seen that, we could have saved some time and just canceled those guys, huh? You could always just do that. If those match, that's going to be what ends up happening. You could save some time that way. Good on that? How could we have known? Because you might have noticed I said tangent, sine over cosine, like there's a way you could have known it. Remember the definition for sine? Remember SOHCAHTOA? SOHCAHTOA. Remember what sine is? It's opposite over hypotenuse. And what's cosine? Adjacent over hypotenuse. See those cancel? So you see how I was telling you sine over cosine is opposite over adjacent is tangent. That's why that's true. All right, anyway, you don't got to know that. Just remember tangent is sine over cosine. So sine squared plus cosine squared is 1. Sine squared plus cosine. We'll use that formula a lot in days to come. Sine squared plus cosine squared is 1. I'll give you a good reason why it's true later. But for now, let's just do what they want us to do. And what they want us to do is to take that 2/3 and pop it in for sine. So that'll become 2/3 squared plus cosine squared is 1. Good so far. I just plugged in sine is 2/3. And I want to find cosine. I want to solve for cosine. So let's begin by squaring that 2/3. That'll be 4/9. Now, how do you solve for cosine? Yeah, exactly. Let's do that. Let's subtract the 4. Get a little scribbly here. Subtract the 4/9, gonzo. So that'll mean cosine squared. Let me bring it over here. Cosine squared is 1 minus 4/9. Now, how do you do 1 minus 4/9? Maybe I should just do it right here, in fact. How do you do 1 minus 4/9? Yeah. Right, yeah. Make that 1. That 1 is 1 over 1. Multiply top and bottom by 9. It's 9 over 9 minus 4/9. It's 5/9. That good? Or you could use your calculator in fraction mode. So cosine squared is 5/9. Was that too quick? I just took that 1 and I made it 9/9. That's a fancy 1, isn't it? Right? I multiplied, I made it look like a fraction, put it over 1, multiplied top and bottom by 9, 9/9. That's a fancy 1. Minus 4/9 is 5/9. So now cosine squared is 5/9. How do I make it into regular cosine? I gotta root it. So root it. So cosine is the square root of 5/9. How do you deal with a square root that's on an entire fraction? Well, you square root the top separately, and you square root the bottom separately. So it's square root of 5. And what's the square root of 9? 3. So there's our answer. Root 5 over 3. So there's cosine. Now, do they want other stuff on this one? So we got cosine. Do they want like the other second answer on that? Does that make sense? We're racing the clock. I don't know if we're going to get through this or not. Let's see what we can do here. Sine of 38 times the cosecant of 38. Sine of 38 times the cosecant of 38. They're saying use an identity. What do you think? Any thoughts? What does it equal?
1.
Yeah. Why?
Because it's the same thing but flipped.
Yeah, remember what cosecant is? I know you're probably new, just getting used to these, and you may not remember them all right away. But let me go back. The cosecant, secant, and cotan, those are upside down, remember? Those 3 on the right are upside down. So cosecant is upside down a sign. So in other words, sine 38, cosecant of 38, what is it? 1 over sine of 38. That's what cosecant is. That's what the 3 trig functions on the right are. They're upside down of the ones on the left. So cosecant is upside down of sine, like secant's upside down of cosine and cotan's upside down of tan. Okay, so what? Well, cosecant is therefore 1 over sine, and you see what happens, right? This is over 1. Cross cancel, it's 1. So whenever you multiply sine and cosecant of the same angle, it's got to be the same angle. Could be any angle as long as it's same. They're both 38. Or cosine and secant of same angle, it'll be 1. Or tangent and cotangent of same angle, it'll be 1. It'll always be 1 because they're upside down of each other. It's like multiplying 5 and 1/5. It's going to be 1, isn't it? That's all there. Secant squared minus, okay, yeah, let me give you, so here's some important identities that you're going to want to use on these problems. Sine squared plus cosine squared is 1. We've already seen that once. Here's another one. Tangent squared plus 1 is secant squared. And you might need a third one, so let me write it down just in case. Cotan squared plus 1 is cosecant squared. So you can put those on your 3x5 card. I'll give reasons why they're true later. For now, we'll take it kind of blind. They are true. We'll learn why later. Give you some reasons later. So, okay, so what does that mean then? What does that have to do with anything? Well, by the way, the 217 doesn't matter at all. Don't let the 217 throw you off. That could be any angle, as long as it's the same in both cases. We don't care what it is. Because these formulas are true for any angle, as long as it's the same angle throughout. So I don't care about 217. That has nothing to do with it. What do I care about? Well, right here, secant squared is equal to, same as, may be replaced with, tangent squared plus 1. Everybody see what that's saying? That's saying, hey, anytime you see secant squared, you can replace it with tangent squared plus 1 because they're equal. They're the same. So when I see secant squared right here, I say, oh, you're just tangent squared plus 1. I'm not even going to write the 217. It's there, whatever. Let me just skip it. And then the other part's still there, minus tangent squared. Everybody see what I did there? So the secant squared is tangent squared plus 1. It's equal to tangent squared plus 1. So replace the secant squared. I'm being lazy and skipping the 217. It's really there. I'm not even worried about it. Tangent squared plus 1 minus the other tangent squared. And so what happens? How do you simplify that? Bye-bye tangent squareds, huh? Equal 1. That whole thing just becomes 1. Good? So secant squared here became tangent squared plus 1, and then the other tangent squared just came down. Now really they're supposed to, I'm being lazy, really there's supposed to be a 217 there and a 217 there. But whatever, they're going to drop out. That's really what you're supposed to write. I'm just skipping the angle because I know it doesn't really matter, as long as they're the same. Okay, so they're giving me cosecant. Yeah, let me write these out. Remember how we have sine. Let me write the whole words out now. Sine, cosine, tangent. I think it's helpful to see the entire words now. Upside down would be cosecant. I've been saying it but not writing it. Secant and cotangent. So let me show the entire words. That'll be helpful for answering this question instead of just the abbreviations. So the abbreviation is CSC and secant and cotan. And this is sine, cosine, and tangent. Anyway, so there's the full words. Now, why am I doing that? Well, because now they're asking us about the co stuff. Do you notice that among those 6 trig functions that we have the word co on 3 of them? We have sine and cosine, tangent and cotangent, secant and cosecant. So we don't have like 6 totally different words. We have 3 words and 3 co's. Why? What's up with that? What's up with the 3 co's? Well, it's pretty tricky. I mean, I'd be impressed if anybody knows. Co comes from the word in geometry, which means complementary. Complementary angles. These are has to do with, that's where we're getting the word co. That's why they're putting co on the trig functions. It's because of the word complementary angles. Now, what are complementary angles? Anybody remember geometry at all? I had a terrible geometry experience in high school and didn't learn anything. I had a great algebra teacher. He's probably a lot of why I'm a math teacher today. He was fabulous, super helpful, super serious about math. But my geometry teacher, that guy was just goofing around. He would just like go to the board for 5 or 10 minutes, kind of scribble around and go, all right, read the book, guys and gals, and he'd sit down at his desk. Anyway, I didn't learn any geometry, but I learned it later. So do you remember anybody have a better geometry experience than me and remember what complementary angles are? What are those? Angles that say, you're such a great angle. Right? They're no, sorry. It's kind of a dumb joke.
On the opposite side of the circle?
Not the opposite. They add up to be something. Remember,
They add up to be 90.
90, good. Supplementary had to be 180, complementary had to be, you don't need to know that, I'm just playing around. But the key you do need to know is it's about 90. So complementary angles are two angles that make a right angle. Anyway, whatever, you don't need to know all that. But you just need to think 90. 90. It's all about 90. Complementary angles are all about 90. Meaning that if you have the sine, say, of 70, it'll be the same as the cosine of 20, because they add up to be 90. Is that making sense? Any two angles that add to be 90, let me write this out. Okay, here, I have some room down here. Any two angles that add to be 90, they're called complementary. The sine and cosine will be equal, or the secant and cosecant, right? Any trig function and his co. And the tangent and cotant. Get the idea? So, any two angles that could be 60 and 30, 50 and 40, 20 and 70, 10 and 80. Anytime you have two angles that make 90, if one of them is like sine and the other one's cosine, it doesn't matter which is which, sine and cosine, secant and cosecant, tangent and cotangent, any function and his co, they'll be equal. That's what we're doing with the whole co thing. Okay, so with that in mind, they're giving me, let me write it out. This is cosecant, it's just the abbreviation for cosecant of 44. Cosecant of 44 is going to be equal to what? He's the co of what? Well, yeah, just take off the word co. Secant. And then what do you do with the angle?
You subtract 90.
So, yeah, take 90 degrees minus 44, because you got to make them total 90, right? So subtract from 90. What is that, 46? 46. So the secant of 46 will be the same as the cosecant of 44, because they total 90. That's what it means with a trig function and his co. If two angles are put in there that total 90, they'll be equal. So they want me to choose, which one's secant? This one, huh? E, and they want me to type into this box 46. That's what they want. Choose option E, type in 46. Making sense on the co thing? Any trig function and his co, if the angles total 90, they're equal. That's why they have the conames. All right, so they're giving me cosine. Find a cofunction, same values of the expression. The answer is, yeah, okay. So they're giving me well, it's right there. Cosine of 2 pi over 7. So that's, here, I'll just write it out. That's cosine of 2 pi over 7. So what's his co-function first off? Let's first find the function, then we'll find the angle. What's his co? Plain sine. He's already got the co, so take off the co. It's going to be plain sine of some angle. Now, how do you find the angle? Now that if they would just give me degrees, I would subtract from 90. That would be easier, right? So when you're in rate, so if you're in degrees, for the co thing, if I can just say it that way, co thing, you subtract from 90 when you're in degrees. Or, now what's the same as 90 in the radian world? Yeah, because remember, pi is 180, right? So 90 would be half of that, pi over 2, huh? That's 90 in the radian world, isn't it? Yeah, so if they're giving you radian, just subtract from pi over 2. Just like we subtracted from 90 in the degree world. So I just take pi over 2 minus 2 pi over 7. Just like on the last one, what did I do? I took 90 minus the angle they gave me, huh? On this one, I take pi over 2 minus the angle they gave me. If you have the fancy fraction calculators, you can just type in 1/2 minus 2/7. You know the pi is there. Just cut out the pi. Take 1/2 minus 2/7, hit the enter button, and it'll tell you something. 7/14 minus, it'll tell you 3/14, I think, won't it? Anyway, I'll do it by hand for you, though. All right, so how do we do it by hand? How do you subtract two fractions by hand?
Same
Common denominator. So I got to multiply top and bottom of this one by 7, this one by 2. And I get 7 pi over 14 minus 4 pi over 14, which is 3 pi over 14. But if you have the nice Casio Natural Display or one of those TIs, you could just type in 1/2 minus 2/7, and it'll tell you 3/14, and then just throw the pi back on. Everybody good with that? Multiply top and bottom by 7, top and bottom by 2, common denominator, subtract them, 3 pi over 14. So the answer is sine of 3 pi over 14. We found the trig function is sine, that's the co, and the angle, 3 pi over 14. We got by subtracting from 90, actually pi over 2, because we're in radians. Good? We happy so far? Let's do one more. I want to use every second. Tangent of 60 points. So you guys have your calculator? This will be super quick. Just take your calculator out, hit tangent. Now you got to make sure you're in degree mode. So do you guys know how to do the mode on your calculator? Every calculator is a little different. I can help you after class if you have trouble. On mine, I got to do mode. But anyway, somewhere on your calculator you have mode. So make sure you go to degree mode and hit tangent. Oops, I didn't hit tangent. Tangent of 60.7. I'll tell you what I'm getting. I'm getting 1.78. What do they want? 2 places? 4 places. 1.78197. So the fourth place, look one to the right, that'll be 1.7820. That's what I'm getting. You guys able to get that in your calculator? Make sure you're in degree mode.